Welcome to Chapter 2, Descriptive Statistics, Tabular and Graphical Displays. In this chapter, we're going to cover different ways to present categorical data and quantitative or numerical data. There's a technique that's referred to as a cross-tabulation table, and you can use it for both types. You can have categorical data for the rows and categorical data for the columns. You can have quantitative data for the rows and quantitative data for the columns, or you can have a mixture of the two. We're also going to look at summarizing data for two variables when we have quantitative data, and it's called a scatter diagram. Some people call it a scattergram. Some people call it a scatter graph. We're going to look at several different techniques for presenting categorical data. These include three tabular forms: the frequency distribution, the relative frequency distribution, or the percentage distribution. There's a couple of graphical forms we're going to look at: the bar chart and the pie chart. Now, the type of graphical display that you want to use depends upon what you want to show. If what you want to show is the distribution of the data, you can use a bar chart, you can use a pie chart, if you're dealing with categorical data. Now, if you're dealing with quantitative data, and you don't have a whole lot of different values, you can use a dot plot. The histogram is probably better than a dot plot if you have a really large data set, because you can put it into groups. Now, if you want to compare categorical data, you can use a side-by-side bar chart, or you can use a stacked bar chart. If you have parts that make up a whole, it's probably better to use the stacked version. Trying to use pie charts to do comparisons, human beings ordinarily just don't do that very well. If you have two quantitative variables where the values are paired together, the scatter diagram is a good way to see whether or not there's a relationship between them. Once you get that scatter diagram, you can also use the trend line to get an idea of whether the relationship is positive or negative, or really even if there is a relationship between them. Now, this is a really busy slide, but it's got a lot of good information in it. The data could be categorical, or the data could be quantitative. Whether it's categorical or whether it's quantitative, you have the choice of tabular displays or graphical displays. Now, some of these display types, you're going to see them in both areas. You'll see them with categorical data. You'll see them with quantitative data. Examples of that include the frequency distribution, the relative frequency distribution, the percentage distribution or percent frequency distribution. Cross-tabulations. You can have cross-tabulations with categorical data. You can have cross-tabulations with quantitative data. You can also have cross-tabulations to where the two types are mixed. For example, you can have the rows being categorical, and you can have the columns being quantitative. Now, purely categorical display types include the bar chart, the pie chart, and some of the other versions of the bar chart. You have side by side, you have stacked. Some display types that are purely quantitative in nature include the dot plot, the histogram. OGIVE is pronounced ogive. And the scatter diagram, when you have two variables when they're paired together. Now, the cumulative frequency distribution and the cumulative relative frequency distribution and the cumulative percentage distribution, you tend to see those with quantitative data. It's possible if you had ordinal level data that you could generate those for categorical data, but ordinarily you don't see that. Usually it's quantitative data when you have those cumulative types. When you generate the table, the cumulative percentage frequency distribution, you can take that tabular display and come up with a graphical display that's referred to as the ogive. Now it's spelled O-G-I-V-E, but it's pronounced ogive. This little example is for the Murata Inn. They asked their guests to rate the quality of the accommodations, and they provide us here with a sample of 20 guests. It's not very easy to just look at the 20 different ratings. This is categorical data, and it's measured at an ordinal level. Excellent is better than average. Average is better than poor. But we don't have any units so that we can figure out, well, how much better is it? There's just not a well-defined unit here, so it doesn't get up to interval level data. Now here we have the frequency distribution for this categorical data. There were 2 out of the 20 that rated it poor. There were 3 that rated it below average. The largest one is above average. There were 9 of the 20 individuals that rated it above average. Now you can take these frequencies and convert them into relative frequencies. All you have to do is to take the frequency and divide it by the total. The 2 divided by the 20 would be 0.1, or you can represent that as 10%. The 3 divided by the 20 would be 0.15, which you could also say that's 15%. But anytime you have a frequency distribution, you can easily convert it into a relative frequency distribution or into a percentage distribution. Now on this slide we have the same information that was available in the table presented as a graph. This is a bar chart. In Excel you would select the column chart, but it's essentially the same thing. Here we have the frequencies on the vertical axis, and the different categories are on the horizontal axis. In Excel, if you select what's called the bar chart, you're going to get the categories on the vertical axis, and you'll get the frequencies on the horizontal axis. But in Excel, this would be referred to as a column chart. Now here we have the 50 cost values for the tune-ups for the Hudson Auto Repair example that we saw back in the Chapter 1 slides. You can't really tell a whole lot about it when it's just in its raw form this way. If you take and sort the data, you can tell a lot more about it. The next slide shows them sorted. Now this particular example doesn't have a really large number of elements in it, so it's possible to take this information and present it in a graphical form that's referred to as a dot plot. It's easy to see here that there's only 152, there's only 157, but there are 4 62s. So when we get to the point on the axis where we have 62, we're going to have 4 dots at 62. There's only going to be 1 dot at 57. There's only going to be 1 dot at 52. But the next slide shows the dot plot that would be generated by these 50 data values. In this case, it's quite easy to determine that the value, the cost value, that occurs most frequently is 62. There were 4 62s, and the most of any other value is 3. And there were several values that occurred 3 times. But if you don't have a really large data set, you can use a dot plot, and you can see how the numbers, how they're distributed throughout the range of the data. You can easily determine what your smallest value is and what your largest value is from this graphical presentation. When you have larger data sets, what you want to do is construct a frequency distribution. Here we've determined approximately what the width of a class should be under the assumption that there's going to be 6 classes. We take the range of the data, the difference between the largest value and the smallest value, and divide it by the number of classes that we want to have. In this case, that width turned out to be 9.5, so we're going to use a width of about 10. So we look to see how many values there are in the 50s, between 50 and 59. How many values are there in the 60s, between 60 and 69? But you just count the number of values in each one of these classes, and you can present this in a tabular form, and it's called a frequency distribution. Now once you have a frequency distribution, you can take the number of elements and divide it by the total and come up with a relative frequency. And that's quite easily converted to a percentage. Just multiply the number by 100 and you've got the corresponding percentage. So this is the relative frequency distribution that corresponds to the frequency distribution. There were 2 values in the 50s. 2 divided by 50 is 0.04. The relative frequency 0.04 is the same thing as 4%. But all you do to get the relative frequencies is just take the number in that class and divide it by the total number. Now the relative frequencies for a data set should always add up to 1. If you convert them to percentages, then they should always add up to 100%, except maybe for some round-off error. The graphical representation for a frequency distribution is called a frequency histogram when you're dealing with quantitative data. If you look on the horizontal axis, the first class ran from 50 to 59. The height of the rectangle is the frequency. Horizontal axis, the second rectangle is running from 60 to 69. The height of the rectangle is the frequency, which was 13. You can easily convert a frequency histogram to a relative frequency histogram or to a percentage histogram. But this is a graphical, a more visual representation of what was in the frequency distribution. This slide shows the percentage histogram that corresponds to the Hudson Auto Repair. To get this one, you take the frequency, divide it by the total, you get the relative frequency, multiply that number by 100, and that converts it to a percentage. So here the height of the rectangle is the percentage value. Sometimes you might want to come up with a cumulative form. There are actually 4 different types of cumulative forms. You have a cumulative less than, you have a cumulative less than or equal, you have a cumulative greater than, and you have a cumulative greater than or equal. Here I'm using a less than version. There were 2 values that were in the 50s, so that means there were 2 values that were strictly less than 60. Now there were, in the 60s, there were 13 values. So when you take the 13 values that were in the 60s and add it to the 2 values that were in the 50s, that means that there were 15 values cumulative that were strictly less than 70. But the cumulative type, you just add them up. All of the numbers, all 50 of the numbers, were less than 110. But the cumulative frequencies can easily be converted to cumulative relative frequencies, which are also easily converted to cumulative percentages. But you've got 4 different ways you can do this: less than or equal, greater than, or greater than or equal. I think in the textbooks, most of them are of this form. They use the less than form. This is another tabular display. Here we've taken the cumulative frequencies and converted them to cumulative percentages. This is the less than version. 4% of the values were less than 60. 30%, which was really 15, were less than 70. Now if you take this information and present it in a graphical form, it's referred to as an ogive. Ordinarily you'll see an ogive, it's going to be tied in to the horizontal axis, but you need a zero value for that. So the widths between the numbers here, between 60 and 70 and 70 to 80 and so forth, they're 10. The original classes from the frequency distribution that were used to generate this cumulative form, they had widths of 10. So the logical thing to do here is to go 10 below 60 and use the number 50. None, 0% or less than 50. And then we go all the way down to 110, and we have 100% of the values that were less than 110. But we can use the values from 50 to 110 to construct what's called an ogive. Now I used Excel to come up with this ogive. The ogive isn't built directly into Excel so that you can generate it as a graph, but I used the scatter diagram feature in Excel, that type of graph, to generate this graph. You can see that 4% of the values were less than $60. 30% of the values were less than $70. 62% of the values were less than $80. You can take this and come up with some approximations. If you wanted to figure out, well, what's the number that corresponds to a fourth of the values? A fourth of the values are less than what? You can approximate that. You can go between 20% and 30% on the vertical axis, get about halfway there, and come over and hit the ogive and then drop it down, and you can get an approximate number that corresponds to that 25%. That's referred to as the first quartile. We'll get into this sort of thing more when we get into Chapter 3. Now this is an example of a cross tabulation. The Finger Lake homes, they've broken them down as to the style of the home and then also the price. Some of the homes, their price was less than $250,000, and some of them were at least $250,000. But you could take that quantitative variable, the price, and come up with these groupings. The home style variable is a categorical variable. They had colonial, they had log houses, they had split level houses, they had A-frame houses. From this information, you can see that there were only 6 log houses that their price was less than $250,000. That was the smallest number. The largest number, the 19, corresponded to the split level houses that were less than $250,000. You can take these frequencies and convert them to relative frequencies. You can convert them to percentages. But this is referred to as a cross tabulation. This one is a mixed type. The one that designates the rows, the price ranges, that's built from a quantitative variable. The columns, the home styles, that's a qualitative variable. But there's a mixture of them here. But you can have the rows and the columns both being categorical variables, or you can have them both being quantitative variables. Now this just shows the two insights that I mentioned based upon the cross tabulation in the last slide. You should also note that when you have a cross tabulation, you also have 2 frequency distributions. It could be for qualitative data, it could be for quantitative data. It just depends on what makes up your rows and what makes up your columns. Now the last topic in this Chapter 2 presentation deals with scatter diagrams. If you have 2 quantitative variables, 2 sets of numbers where they're paired together, You can plot one of them on the horizontal axis and the other one on the vertical axis. Ordinarily, the one on the horizontal axis is called X and the one on the vertical axis is called Y. But you can look at the relationship when you plot the points to see if there's a positive relationship, a negative relationship, or if there's just no relationship. There's a technique referred to as regression where you can come up with the equation of a straight line that's as close as possible to all the different points. And in Excel, when you generate the scatter diagram, there's an option to put a trend line in it. And it's real simple just to check the box and say, I want to see the trend line. And it'll put one in there for you. This slide depicts a positive relationship. The green dashed line in the middle is the trend line. But as the X values get larger and larger, the corresponding Y values are also increasing. This slide shows the negative relationship. As the X values are increasing, the corresponding Y values are decreasing. And when you fit it with the trend line, you can see that that line has a negative slope. This is an example where the two quantitative variables apparently are not related to each other. As the X values increase, sometimes the Y values go up, sometimes they go down. When you fit those points with a straight line, the slope is zero. We're going to cover what's called least squares regression when we get into chapter 12. This example is for the Panthers football team. They're looking to see if there's a relationship between the number of interceptions in a game against the number of points that were scored. They're paired up by the game. In one game where there was one interception, there were 14 points scored. In another game when there was just one interception, there was 17 points scored. There were a couple of games in this data set where there were 3 interceptions. One time there were 24 points scored, the other time there was 30 points scored. Only one of these games had 2 interceptions, and in that game there was 18 points scored. You can take and graph these points and you can look to see if there's a relationship. So the 2 games where there was 1 interception, one of them had 14 points, and that's the vertical axis. The other one looks like it's about 17 points. The game that only had 2 interceptions, that looks a little bit taller. It's 18 points, I'd say. Then the 2 games that had 3 interceptions, one of them had 24 points and the other one had 30 points. But when you take those 5 data points and fit them with a straight line, you can see that that line has a positive slope, which indicates a positive relationship between those 2 variables. You get more interceptions, you score more points. Now this concludes the presentation over Chapter 2. Remember, the recommended completion date for the Chapter 2 homework is July the 7th. The next video is going to deal with Chapter 3. I'll probably split that up into 2 videos. But until next time, I'll just keep working on these videos.